Java, Chapter 13, start talking about abstract class and interfaces. How we do that in Java. So first, what is an abstract class? So you have to learn how to write simple programs, right, to create display GUI components. Right, source code, you have to learn how to create an interface, right? No, you haven't, but you use them. So this chapter we're gonna learn how to create interfaces too. So you can design an abstract class. You can look at more into a wrapper class, like we will look at integer class, but this is going to talk about big integers, big decimals, and number class, and this is an abstract class. Like big integer, big decimal, they extends from number class. So we can look at calendar and Gregorian calendar classes and common behaviors of the object and interfaces when you use them. So interfaces and define class that implements the interfaces. We can look at that. Define natural order using the comparable interface. So comparable is an interface. Like coordinable is also an interface, and we can learn how to use them and why interfaces. And explore the similarities and differences among concrete classes, abstract classes, and interfaces. Design the rational class for processing rational numbers. Design classes that follow the class design guidelines. So look at this UML diagram. So we create a class named geometric object, which is an abstract class. Okay, and this abstract class has three attributes: color, field, date created, and protected constructors. Geometric object with default constructor, no parameters, and with the parameters color and field, Boolean type. Get color, set color, set field, get date created, to string, get area, get parameters. So UML looks exactly the same. And circle extends from geometric object, and rectangle extends from geometric object. Now, for this UML geometric object, we said we're gonna make get area, get parameter as an abstract methods. If you remember, before we extend geometric object, but circle has its own get area, get parameter, has rectangle, get area, and so they all have their own and calculate their own ways. That's why it's very important that if I want geometric object to include get area and get parameter, we want to make it as an abstract. Abstract methods. That means we don't want to implement how we calculating the area yet, but let the circle do implementation once extended. So the class that extend an abstract class require to implement the abstract methods. We only define the abstract method as the headers, like in this example. Look at the get area right away now. See, these are the abstract. We only define the header and we just put keyword abstract as the modifier in front of the method get area. But we don't implement the code here because the way we implement it, we don't know. Circle has its own way to do get area, right? Pi r square. Which is rectangle, they have its own way like side by side. So that's why we create the abstract methods. Get area, also get parameters, not implementation. But let the program that using it which is extend circle, extend from that, rectangle, extend from that, they are required to override. See that? Override. Just like the concept of overriding methods in the inheritance, which is inherit get area method, which is an abstract method, is required to override this method to find radius, to find area and to find parameters. And this also have get diameters included, but for rectangle, we have height, width, constructors, get width, set width, get height, set height, and we define our own get area, which is extended from, these are inherited from the abstract class geometric area. So that's the benefit of doing the abstract, right? So we want to make sure that the rectangle, geometrics always have get area and get parameters, but the way we calculate is different, so that's why we as abstract and let the children implementing them. The override here just refer that you actually implementing the method from the abstract class, so make the compiler know that you meet the requirements that you implemented, because you're required to implement it. Like the children who extend abstract superclass required to implement all the abstract methods. Otherwise, compiler will not allow you to pass the compile. So add the annotation override on those methods. An abstract method cannot be contained in a non-abstract class. So if you look back, so we are required to say abstract class. In the class, so you have to define abstract modifier. Otherwise, it's not allowed to have abstract method. If a subclass of an abstract superclass does not implement all the abstract method, the subclass must be defined abstract. In other words, in a non-abstract subclass extended from an abstract class, all the abstract methods must be implemented, even if they are not used in this subclass. If not implemented, that means subclass also an abstract. So object cannot be created from abstract class. You can instantiate an object from abstract class, but you can still define its constructors, which are invoked in the constructor of its subclasses. For instance, the constructor of geometric objects are invoked in the circle class and the rectangle class. So go to circle, rectangle, set height, abstract class without abstract method. A class that contains abstract methods must be abstract. However, it is possible to define an abstract class that contains no abstract methods. In this case, you cannot create instances of the class using the new operator. This class is used as a base class for defining a new subclass. A subclass can be abstract even if its superclass is concrete. For example, object class is concrete, but subclasses such as geometric object may be abstract. A subclass can override a method from its superclass to define its abstract. This is rare. Subclass can override a method from its superclass to define abstract. It's rare but useful when the implementation of the method in the superclass becomes invalid in the subclass. In this case, the subclass must be defined abstract. You cannot create an instance from an abstract class using a new operator, but an abstract class can be used as a data type. Therefore, the following statement, which creates an array whose elements are of geometric object type, is correct. So like that, we can define as the type. Because we only create an array as a type, because this new is for array, not instantiate object yet. Abstract number class. So this is a class named number, and these are the wrapper class that extends from abstract class number. You can look at an example of large just numbers that using this. So create a list, add all the numbers, which is any type, because we make it as a type number. So that's why we can have any type of number, integers, double, big integer, big decimal, because they all extends from abstract class. Right. And get largest number, just return number. Example of abstract class for calendar and Gregorian calendar. Calendar is an abstract class, which Gregorian calendar extends from that. So calendar has constructor set, get the values, and field, like returns the value of the given calendar field. Set the year, month, day, get actual maximum, right, value that the specified calendar field would have. Add, you can add the fields and amount, get time, set time. Now Gregorian calendar just extends from that, but constructing using the constructor of Gregorian calendar, which you specify the year, month, day of month instead of doing the values. So the abstract calendar class and its Gregorian calendar subclass, an instant of Java util date represents a specific instant in time with millisecond precision. Calendar is an abstract-based class for extracting detailed information such as year, month, date, hour, minute, and second from a date object. Subclasses of calendar can implement specific calendar systems such as Gregorian calendar, lunar calendar, Jewish calendar. Like currently, Gregorian calendar for the Gregorian calendar is supported in Java API, so it's already implemented. You can use new Gregorian calendar to construct a default Gregorian calendar with the current time, and use new Gregorian calendar to construct a Gregorian calendar with a specified year, month, and date. The month parameter is 0 based. 0 is for January. The get method in calendar class. This method defined in the calendar class is useful to extract the date, time, and information from the calendar object. The fields are defined as constant like year, month, date, hour, hour of day. So in 24 hours, right? Not 1 minute. Second, day of week, day of month, day of year, week of month, week of year, AM, PM. You can indicate that. So let's look at example. So we instantiate Gregorian calendar, which is a type of calendar. This is an abstract class. And we set a new date, right? Current time. Just bring out this is current time. Year, we can do calendar.get since we have calendar object created. So we can do year, month, date, and so